Good morning. So, as a convener of IA student chapter, once again, I welcome you everyone for this guest lecture on SCADA and grid operations. So, maintenance of the grid is one of the most challenging tasks, especially for the power system operators. So, as we are the electrical engineering students are about to graduate, so definitely we must have an insightful knowledge regarding the issues and challenges that have been faced by the power system operators in maintaining the grid. So, to fulfill the bridge between industry and academia, we have conducting these kind of guest lectures. So, mostly the problems that have been arised in the grid operations is maintenance of the frequency. So, maintaining the frequency is not an easy thing, which usually depending upon an equilibrium between load demand and the generation. So that everyone had know. So that is one task. Second thing is, so the grid has been integrating with renewable energy sources. So with the motto of cutting down the usage of fossil fuels and also as a solution to the global warming issues. So, renewable energy sources are more intermittent in nature. So, we can't predict the sources of renewable energy at an instant of time. So, these issues are having a crucial role, especially in operation of the grid. So, we are lucky to have a person like Kiran sir on the grid operations as well as this SCADA. So thank you, sir, for accepting the invitation on behalf of IA student chapter as well as from the EEE department. And I would like to thank HOD Naresh Garu and the faculty of EEE department for their support and the smooth conduction of this event. And I would like to thank Principal sir for giving the necessary permissions. And I would like to extend my gratitude towards our college management, Secretary Badri Prasad sir and Chairman Vasireddy Vidyasagar Garu for providing everything and always encouraging us to conduct such kind of events for the students as well as the faculty. So from this lecture, not only the students will get benefited, so this is also important for our faculty to know the challenges that have been involved in the grid operations. So I request everyone to make use of this opportunity to grab some of the valuable information regarding the SCADA and grid operations. Thank you.
Thank you, sir.
Respected Principal sir, he is in online meeting. He will join shortly with us. And today's chief guest and resource person, M. Kiran Garu, Deputy Executive Engineer. Sir has the vast experience, practical experience regarding the SCADA and the grid operations. And I strongly believe that this type of practical exposure is required for all the EEE students. So we know at least the fundamentals of the grid operations and the basic principles of the SCADA. And especially as per the industry requirement is concerned, all the students are required to update their technical developments and its applications in electrical engineering also. Most of the students, we feel these courses like data science, machine learning, cyber security, right? So data analytics, all these courses belongs to particular branch, computer science engineering. But now the scenario is completely changed. The companies are looking for all-rounders. So as you know, this is the famous word in which game? Cricket. So batting, fielding and bowling they are expecting. At the same time, so minimum academic percentage as well as basic fundamentals of all the technical developments. Particularly these developments, applications in electrical field definitely will be placed in the better position. Okay. And this type of practical exposure very much useful, and this type of guest lectures, especially from the industry. Okay. So it can bridge the gap between the industry and the academia definitely. And I request you all, please be attentive and interact with the sir. He is ready to give the maximum extent information and the possible information regarding the SCADA and the grid operations. At the outset, I thank Principal Sir and Management, Chairman Sir and Vasireddy Garu, Badri Prasad Sir for their continuous support and encouragement to organize these type of programs in the campus, especially in EEE department. So, as per Chairman Sir is concerned, always so he focused on the practical issues in that particular aspect. So, especially our seniors are calculating campus energy management in our campus with respect to load calculations, energy consumption of each block, and they are planning to develop the electrical drawing by using AutoCAD. They are learning all the skill-based courses, including the data analytics, Power BI. So we have included all these smart grids, electric vehicles in the curriculum itself. So as these are the emerging courses and which will be useful for you with respect to the industry requirement. Okay. So in this connection, this guest lecture will be also very much useful for you. And I request you all, please be the attention and okay. So try to acquire the knowledge as much as possible. And at the outset, on behalf of the VVIT EEE department, student chapter, I especially thank our resource person for accepting our invitation and for sharing his knowledge to VVIT EEE students. Thank you, Nandal.
Thank you, sir. Sri M. Kiran, sir. Sir completed BTech in the stream of Electrical and Electronics Engineering from REC Warangal. He joined Andhra Pradesh State Electricity Board as Assistant Engineer in 1995. Sir has worked in various wings like Substation Maintenance Construction Wings and SCADA Wings. He got promoted as Deputy Executive Engineer in the year 2005 and worked in SCADA and Andhra Pradesh State Load Dispatch Center and Construction Wings. At present, Sir is looking after the field SCADA from ALDC, Nunna. It is a great pleasure to welcome such a noble personality, Sri M. Kiran Sir, to start the session.
Have you understand the terminology? So what is grid? How we are monitoring grid? At what level? State level, regional level, national level. So I need to give the inputs to the system operators. I need to give the data to the system operators. So, first time this is SCADA. SCADA means supervisory control and data acquisition. Okay? So this is data. So what is data? Today, based upon the data, so many subjects have come. Data analytics, data structures, data mining, data analysis. So many subjects have evolved based upon the data. So what is this data? Please quite noises. Or if you can talk me, I'll be silent. Okay? So what is this data? In terms of electrical terminology or signal, how can we classify data? Broadly, how can we classify data? Can anyone say? So data basically can classify it as two types. One is analog, one is digital. Yeah, good. Basically analog and digital. So all the data, all the phenomena in and with me is in analog nature. Light, velocity, viscosity, current, flow, everything, levels, anything you take, data will be in analog in nature. Means it's in a waveform. Okay? You need to understand the logic. They are most useful for your future. So analog and digital. So all the signals of connected to electrical field are in analog nature. You take voltage, current, voltage, whatever frequency, whatever it is. But I need to represent them on my system. What my system understands? Only 0 and 1. Okay. Again, analog can be divided into two types. What there? Analog input, analog output. Digital input, digital output. Anna, what do you mean by analog input? It is a range of electrical signal. It is a range of electrical signal. You take voltage, you take current, you take frequency, you take velocity, anything you take. It has a range. It has a minimum range and maximum range. So with this signal, I can measure the quantity, analog input signal. And also, what is DI signal? Digital input signal. It represents the state of a signal. Anna, it has two states only, 0 and 1. Whether my bulb is on or off, whether my circuit breaker is on and off, whether my switch is on off. So with this signal, with this type of signal, I am able to read the status of a device. You got it? Okay. So why then analog output and digital output? With this type of signal, I am able to read the status, and with this type, I am able to control this one. I can control a valve, I can control a motor contactor, I can control a breaker from my remote location. So sitting in my control center, I can control the devices with this signal. Suppose in the case of a summer, we used to give power shutdowns for an entire village, for a 30 villages at once. How do we do that? Using these signals. So from my system, I can give a DO command which will execute tripping of the breakers in 132 by 33 kV stations. Thereby, 33 kV feeders will go down. I will not rush to the station and I will not trip the breaker. Using the control center, I am able to. So basically, input-output signals are how many types? 4 types. Analog input-output, discrete input-output. Then how to transmit these signals? So what are the devices required? So SCADA basically, ivi kaakunda meeku counters untayi, counters for reading energy, okay? You have to understand the basics of these signals first, okay? Then counter. So this is all comes under the instrumentation parts. So SCADA comprises of field technology, field, communication and control centers. We have field devices, we have communication systems, we have control centers. So what will be there in the field? What will be there in the communication system? What will be there in the control centers? Now I am touching the field part. So to provide the data to the control centers, I must first understand the signals first. So these are the signals. So how to tap these signals? What are the devices required? Okay? So suppose I take one substation. So I take one substation. So if I had any queries or any doubts, you can raise me. You can ask. Good. So my basic thing is I need to provide the data to the system operator. So we are operating AP SLDC, AP system operation from the AP State Load Dispatch Center at Gunadala. Okay? One state bifurcation, we have our own beautiful load dispatch center. So sitting there, our system operators will be operating the grid, they will be monitoring the grid, and as well they will be controlling the grid. To monitor the grid, what I told you, the load generation balance. So they must have what is the total load connected to the system, AP system right now. as well as what is the generation there, available generation is there. So what is the difference? How to mitigate this difference? How to balance this one? So to provide a load system, so what is the required? Suppose we have number of substations in the number of substations. So data from substations, data from generating sources. Generation sources. Substations ante enti? We have 400 kV, 220 kV and 132 kV. We have around 15 numbers of 400 kV stations, more than 100 220 kV stations, more than 300 130 kV stations. So I need to provide telemetry system in all these networks. Some are substations kuda. Have they gone to any substation, sir? Have they visited? So you better plan to visit a substation. Then you will come to know how it looks like. Okay? So ఈ సబ్స్టేషన్ నుంచి నేను డేటా ప్రొవైడ్ చేయాలి. ఓకేనా? సో ఈ సబ్స్టేషన్ కూడా there are two types. One is automized, one is conventional based. Already automated substation, one is conventional station.